Hello everyone. So in this lecture we are going to understand the addressing modes that are available in computer architecture. So let us understand first what are addressing modes. So addressing mode is nothing but it is the way in which the operand is specified in an instructions. So it defines that how the effective memory address of an operand is calculated, right? So that effective memory address, right, that is important. So first you need to understand what is effective memory address, right? So the effective memory address, it's the actual address where your operand is available, right? So you are going to work with the data, right? Suppose you need to do the arithmetic operation or increment operation or a decrement operation, any of the operation within the ALU. So you need that data, right? That operand you need, and that operand is stored somewhere in the memory, right? So that address where it is actually stored is known as effective memory address, right? So effective address, so that how to fetch that effective address, that comes under addressing modes, right? So how the computer execute an instruction, that I have explained you in earlier lecture as well, then also I'll revise it bit, that there is a three-phase: fetch, decode and execute, right? So fetch means what? Processor retrieves the instruction first, right? Then decode, in decode it will decode the instruction and fetch the data, that means fetch the operand available, right? And then it will process, it will perform the particular operation, which operation is given by the instruction, right? So this addressing mode comes under this decoding phase, right? So let us understand that how many addressing modes are available, right? So there are number of addressing mode, let us say immediate addressing mode, direct addressing mode, indirect addressing mode, registered, index, register indirect, based index, relative addressing mode, stack addressing mode, implied addressing mode, and auto increment, auto decrement addressing mode, right? So I'll explain you all this addressing mode one by one. Some of the addressing modes are very famous, like you might be heard of direct addressing mode, indirect addressing mode, then registered, then immediate, right? Most frequently used are like register, direct, indirect. In the examination also you will get the question that what is the difference between a direct addressing mode and indirect addressing mode. I'll make a video separate for the difference between a direct and indirect addressing mode. So let us understand first the immediate addressing mode, right? So the immediate addressing mode, in that we don't have any effective address. That means my operand is directly available in my instruction, right? Here let us see this example. So that is move AX comma 0005H, right? So here 0005H, it is operand itself, right? And it will move the value, that 5, into the register AX, right? So here in immediate addressing mode, the data is not stored in memory, right? It is directly available in your instruction, right? In the next one you can say this add BX comma 10, that means I am adding the value 10 along with the value that is available in the register BX, right? So this is immediate addressing mode, where data is not stored in the memory, right? And it is good when we need to load the constant values, right? Registers, in a register I need to store the constant value. At that time it is a very useful, right? Next we'll move ahead with direct addressing mode, right? So direct addressing mode means what? Your data, your operand is stored in memory, right? And that memory address is available in your instruction, right? So that means what here, this example we are having, right? So suppose I am having this memory, right? So in this memory, let us say at a location 1 2 3 4, right? At this is the hexadecimal value. So at this location, suppose I am having a value called 15, right? So this is my operand, right? For this operand, my effective address is 1234, and in my instruction I am having move ax comma 1234h, right? So what it will do, it will move the data available at this address, and this address is known as effective address. As I told you earlier, effective address is the actual address where your data has been stored, right? So this is the address 1234. At 1234 what is available? 15 is available. So what it will move in the register ax, it will move the data 15, right? So that is very simple, and that's your direct addressing mode, right? Now next we have, that is indirect addressing mode, right? Now as its name suggests, it's not a direct, right? So we are not directly having the effective memory address, right? We don't have effective address directly, but this effective address is stored somewhere in another address, and that address is available in my instruction, right? So let us say, suppose I am having instruction that is like move ax comma 1000h, right? So that means what, in my memory somewhere at location 1000 I'm having the value 2000, right? And here at 2000 I'm having the value 50, right? So in this 1000h is not my effective address, so it's not my effective address, but what it will store, it is already having, it stores the effective address. So move ax 1000h, that means it will go to this 1000 location. It is holding the value what, 2000. So now it will go to 2000, and at 2000 I am having the value 15. So it will move, or it will store the value 15 to the register ax, right? So here the effective address is again 2000 only, right? So in a memory, effective address is stored, so it's a indirect, we are getting the data indirectly, not the direct one, so it's called indirect addressing mode, right? So I hope you understood this indirect addressing mode, right? Now the next one is register addressing mode. Again, it's very simple. Till now we used memory for storing the operand, right? In a register addressing mode, we use registers to store the data, right? So in a memory, along with the common memory, we have the register as well, register A, B, C, D, E, right? So here the instruction is add ax comma bx, right? So in the register B, suppose I am having a data that's a 20, right? And in ax, suppose I am having a data that is called 10. So what it will do, it will add 10 plus 20. This 10 is available in ax, right, register, and this 20 is available in the register bx. It will sum up this, and the answer is again stored in ax, right? So this is your register addressing mode. That means the operand is available in CPU register. In the register I am having my operand, and I am accessing that directly from that register, right? Similar way, this is move cx comma dx. That means whatever data is available at d, that is like suppose 3, right? So I am transferring that data from 3 to from register D to register C, right? So it will be available in the register D as well, it would be transferred to register C as well, right? So this is about register addressing mode. Then next we have index addressing mode, right? Now index addressing mode, that means what, that we need to calculate the memory effective address, right? First after this, whatever addressing mode we are having now, in that we need to calculate the effective address, right? So how will calculate the effective address? By adding the constant value, or we can say displacement, right? So we are having one index register, right? An index register along with that, so we are adding that value, and whatever answer we are getting na, that answer, that is my effective address, right? And from that effective address I will get my data, right? So suppose here I am having move ax comma bx plus ai, right? So bx, in bx I am having, let us say 2000, right? And this SI, that displacement, so that displacement is 10, so ultimately it will give you me it will give us 2010, right? So at the address 2010, whatever data is available, whatever operand is available, that operand I am transferring to my register A, right? So that is index addressing mode, where we have an index register, and index register, what it will contain, it will contain the displacement, right? And that would be added to the other value, right? And that's how we calculate effective address, right? Then the next is register indirect addressing, right? Again, register indirect addressing, that means what, that we need to use a register, right? So this instruction is specifying one register here bx, and that holds the effective address, right? I told you effective address, right? So in index addressing mode we calculate the effective address. Here no need to calculate the effective address, because the effective address is available. But where it is available? So it is available in register, right? In indirect addressing mode, if we don't have register indirect addressing mode, what we saw already, that indirect addressing mode, the effective address is available in memory, and that memory address is given in my instruction, right? Here the effective address is available in some register, and that register value is available over here. So move ax comma bx, that means at the bx, suppose in register bx I am having the value 2000, right? So it will first fetch that 2000, and whatever data is available at this 2000, let us say that data at that location available is 15, so it will transfer that 15 to this ax register, right? So first it like instruction points to a specific register, that is bx over here, then register holds the address, I told you this, and then it will fetch the operand, right? So this is register indirect. So it's a combination of register addressing mode and indirect addressing mode, combination of both, that makes register indirect, right? Now next we have that based index addressing mode. Again, this is something similar to index addressing mode, right? So here we have a base register, then we have index register, right? And we have a displacement, that is optional, right? And by adding up this all, will get effective address, right? And from that effective address we can fetch the data, right? So this is like for suppose we are having a very complex data structure, and we need to avoid the collision. At that time we can use this base index addressing mode, right? So here we have the base register, that's a bx, right? Index register, right? I have shown it here as a ir index register, here it's a si, right? So index register, and then this is my displacement, this displacement is optional, right? So first it will sum up all this, and whatever answer you will get, let us say for example 1111, you will get this as an answer, right? So the data available in your memory, right, at this particular 1111 location, whatever data, suppose that is a 5, so that data is transferred to your register 5, right? So this is about based index addressing mode, right? So next you are having that relative addressing mode, right? So what is relative addressing mode? So here effective address, right? So it's directly a displacement, you are having some displacement, and your program counter, right, it will add the displacement in the value of the program counter, right? So after that, whatever data you will get in that whatever location, right, that number, that is the address, right? At that address, whatever data you will get that will be added, right? Suppose this is jump $+10, that means whatever the current program counter's value, PC's value, it will jump 10 bytes forward, right? 10 bytes forward to that. Suppose PC's current value is 1 2 3 4, right? So it will jump 10 bytes forward, so it will 1 2 4 4. Now the PC's value is 1244. Now the instruction is load R1 comma PC plus 20. So PC's value is 1244 plus 20 it will do, right? So 1244 plus 20, that's a 1264, and at this location whatever data is available, that data, this is my effective address, right? I told you earlier as well, effective address is what? That is the actual address of your operand, right? So at this location 1264, whatever data, whatever operand you will get, that operand is loaded to this register R1, right? So this is your relative addressing mode. Then next you have stack addressing mode, right? So as its name suggests, stack addressing mode, that means it is using stack. You have push operation, you have pop operation, right? Push, that means pushing to the stack. Pop means popping out the data, removing the data. And as you know that stack use a last in first out LIFO nature, right? So if you are pushing the data, suppose this is your stack, right? You are already having some data like 5 7 something, right? And your stack pointer is here, right? So whenever you push some data, that would be stored over here, and stack pointer is incremented. When you pop the data, that data is deleted and your stack pointer is decremented, right? So here the same thing, stack addressing mode, we are making a use of a stack push AX. That means whatever content of AX that I am having in AX, that is pushed to the stack. And pop BX, that means whatever data currently stack pointer is having the value 7, right? So 7, that 7 is transferred into the register BX, right? So that is a very simple stack addressing mode. And then the one more important, that is implied addressing mode. Now in this also no need to count the effective address. In this, effective address doesn't come in the picture, because the instruction itself defines the what I can say, it itself defines the operand. Let us say for this example, this INCAX, right? So INCAX, that means its meaning itself is increment the value in register AX, right? So the instruction itself specify the operand. Let us say the second one, CLC. CLC means what? Clear the carry flag, right? So it is denoting that I want to clear, and what I want to clear, that's a carry flag, right? RET is return from subroutine, right? So that doesn't need any effective address or explicit address or any registers for the data, right? So that implied addressing mode, that means the instruction itself have the operand, Getting this? And the second name, it's like implied addressing mode, is also known as implicit addressing mode. Why? Because the instruction itself implicitly specify the operand, right? So that is like instruction first it is decoded, then the operand is identified from the instruction. There are no explicit address or register is provided, right? And the operation is performed. That is your implied addressing mode, right? Then the last one is auto increment and auto decrement addressing mode. So both are same, only the thing is in one there is an increment, in other there is a decrement, right? So what it will do, so there is a like it's a register is holding one address, like effective address, operand's address, that is what effective address, right? So register is holding effective address, right? And that address is automatically either incremented or decremented. In increment mode it is incremented, in decremented mode it is decremented, right? And after that the operand is accessed, right? So it is used for like suppose we have a sequential data stored in memory, or we are working in a loop, right? So at that time this is very useful, right? So here there is example that load r1 r2 plus, it's a post one, plus is post, right? So first what it will do, that whatever in r2 whatever address is available, from that address it will, this r2, in r2 my effective address is available, right? So whatever effective address is available in r2, from that particular address it will fetch the data and it will store the data, it will load the data in r1, right? And after that automatically this effective address is incremented, so r2's value is updated with incremented effective address. Getting this? So the next time when you go for this, so it will give you the next data. Understood? The similar way here I am having store r3 minus r4. Now it's a pre, right? So pre means what? First it will decrement, right? So suppose r4 is having some effective address, so first what it will do, it will decrement the effective address. Suppose there is 1 2 3 4, right? So first it will decrement and it will become 1 2 3 3, and then whatever effective address is available at this location 1 2 3 3, so this is your effective address. So whatever data is available at this location 1 2 3 3, that would be stored in the register r3, right? So that is about auto increment and decrement, right? So I hope you understood this. So in this lecture we have seen 11 addressing modes, right? All addressing modes are important, but the very popular are, as I told you, that register addressing mode, direct addressing mode, indirect addressing mode, right? Register indirect addressing mode, immediate addressing mode, these are the most popular one. Then also based on the application and usage we use this different addressing mode. So I hope you understood all this 11 addressing mode, and if you have any doubt you can ask, right? So thank you very much, thank you for watching this video.